Okay, let's look at one example in section 8.3, and then we go to section 8.2, and then go to section 8.3. So we say the okay, if we have the nth root of a raised to n, this is similar to a. And or now n a raised to n equals the absolute value of a. And is even. So if there is a negative here, when it is odd, then here you should have odd. So if it is even, then if there is a negative, then it means that you cannot get the one, the square root, unless the roots, unless it becomes actually the complex number. So in our case now, we don't deal with the complex numbers. Also, the square root, the nth root of a n all over b n is the same as a all over b. It is the same as a all over b, and it is also equals to the nth root of a raised to n all over the nth root of b raised to n. Okay, so that is what we said. Then, example. Another example. Find the seventh root of n raised to 2/6 all over n raised to 3. Find the seventh root of that. So actually, it is the same as simplifying the values which are inside that root, right? So since the bases are the same, then we can actually simplify what is inside here. So it is the same as the seventh root of n raised to 26. Taking this n up here, it becomes what? Becomes negative. So since the bases are the same. So this is equals to the seventh root of n raised to what? Now, this is similar to using the property that we did, where we also said the root of a, b is the same as the root of a, the root of what? The root of b. Now, using that property, we can expand this. We can expand this. So this is similar to the root of 27. This one is n raised to what? 21 multiplied by n raised to what? N raised to 2. Now, using this property here, then the root of 7 n multiplied by n squared is the same as the seventh root of n raised to 21, and then seventh n raised to 1 raised to 2. And finally, this is equals to n raised to 27 over 1. 21 over 7, which is equals to n raised to 1. And this, since this cannot be divided by this, then it is the same as that. And we have completely simplified that. We have simplified. Now, since the root there is odd, then we don't put the what? The absolute value. The absolute value. Okay, another one, another example. We have c raised to 4 all over c raised to 16. Simplify that. Simplify that. So using this property here, then this is the same as, you can actually simplify the inside one, or you can actually get the roots of each one. So it is the same as the root of c raised to 4 all over the root of 1. The root of c raised to 16. And this is similar to what? C raised to 4 is C raised to 4 is
Professor, for those of us online, can you move the paper down just a little bit? Thank
that.
you.
Okay.
That works.
All right, so C, so this one is, now C raised to 4 is what? The square root of that is C raised to 2. All over C raised to 16 is what? 4. So C raised to 4. Now simplifying this, simplify, and then this one is what? Absolute value, since that one is even. So we can simplify this. Then finally, this is the same as what? 1 all over the absolute value of C raised to what? The absolute value of C raised to 2. Yeah, there is a mistake that I made in my notes. So when you go home, you can correct it. Okay, now let's come to section 8.3. 8.3. So the nth roots of A is similar to A raised to nth root of A is similar to A raised to 1 over n. Now, example. Simplify y raised to 1 over 2 multiplied by y raised to 3 over 4. Y raised to 1 over 2 multiplied by raised to 3. So if you look at the first one here, this is the same as what? The square root, right? How about the next one? What about the next one? The fourth root of y raised to what? 3. The fourth root of y raised to 3. Now, looking at this using the properties that we did in section 5.1, then since the bases are the same, then we can add the what? The power. So 1/2 plus what? 3 all over 4. And this is equals to y raised to what? So the least common multiple there is 4. So 2 plus 3, which is 5 over 5. Now, how can you write that one in radical form? So this is in exponential form. How can you write that one in radical form?
Fourth root of y to the power of 5.
Yes, so this is actually similar to the fourth root of y raised to 5. Since we know that a raised to 1/n is the same as the nth root of a. Another example number 2. Simplify 9x2/5 y 3/5 raised to 5 raised to 5. Now, this is almost similar to the one which you were doing. So also using properties in section 5.1, then we can distribute the what? The power there in each one of them. So this is equals to 9 raised to what? 5/2 multiplied by x raised to 2/5 raised to what? 5/2 multiplied by y raised to 3/5 raised to what? 5/2. So you actually do it in each one of them. Some of you are ignoring that constant there. You also need to raise by the power. So, and now this is equals to, now this is similar to in radical form, 9 raised to 5/2 is just the same as the square root of the square root of 9 raised to 1. Square root of 9 raised to 5. Yeah. And then multiplied by x raised to 2/5 raised to 5/2 is the same as 2/5 multiplied by what? 5/2. Okay. Okay. Then multiplied by this y again is 3/5 multiplied by what? 5/2. Now, finally, this is the square root of 9 raised to 5 multiplied by what? So this and that cancel, this one and this one cancel. So x, 5 and 5 cancel, 3, and then y, 3/what? 3/2. Y 3/2. Are we together up to there? Are we together? So you simplify. So distribute this power to each one of them. That is this one. This. Then this 9 raised to 5/2 using this property here. Then it is similar to Now, now this is also equals to, you can factor out x, the other side, x, the square root of 9 raised to 5, and then this y raised to 3/2 in radical form can be written as what?
Square root of y.
The square root of y raised to 3. Square root of y raised to 3. Now, using the property, this property here, so using this property here, then this is also equals to x, the square root of what? 9 raised to 5, y raised to what? Y raised to 9 raised to 5. Y raised to- Again, if you look at 9 raised to 5, we can still do what?
Simplify.
We can still.
Wait, sorry, where did the x go?
X is here, outside here.
Oh, okay.
Yeah.
I'm blind. My bad.
You're fine. So X is here. So we can still simplify 9 raised to 5, which is the same as x, the square root of 9 raised to what? 4, 9. And then this 9 can also be what? 3, right? 3 square, right? So this 9 can also be, so basically, we can write this as x outside, and then this 3, this 9 can be what? 3 raised to what? 2, right? 3 raised to 2, and then also raise this one to what? 5, right? And then this is y raised to this. Right. Okay. So in this case, this is equals to x, and then the square root of what? The square root of 3 raised to what? 10. And then y raised to 3. Now, finally, this is equals to 3 raised to 10 is what? And the square root of 3 raised to 10 is 3 raised to 5. So x 3 raised to 5. And then the square root. 3 raised to 5 is 3 raised to 5 is 201. This is equals to 243 x. 243x. Then the square root of y raised to 3. Square root of y raised to 3. So here you get a square root. So when you get a square root of 3 raised to 10, is 10 all over 2, which is what? It's 5. You factor it out. So 3 raised to 5 multiplied by x. So 3 raised to 5 is 3 5 times. You get 243 by x, and then the square root of y raised to 3. Now, also, we can still write this in this form. In this form. So finally, this can be written as 243 x. Y raised to what? Y raised to what? 3. Y raised to 3. Any question up to there? So you when you're doing your exam, so you make sure you follow the steps so that you don't get confused. So you write stepwise. Doesn't matter the size. So you make sure you write each step. You write each step. Okay.
On Newton, do we have to write it out like that, or can we just leave it like where it's all just like the x under the square root and then 3 10 and then y3? Or do we have to simplify it all the way down?
It
On
doesn't
new.
matter. It doesn't actually matter. But in your exam, you can be told to write in radical form. So in radical form, it's in this form. But in exponential form, it is just in this form. So if it is not specific, so you can write it in any form, okay?
Yeah.
All right. Okay, another example, if we are told to write 8 raised to 4x with rational exponents. Rational exponents. So this is this is actually 5. This is in radical form. Now you're told to write it in exponential form. In exponential form. So again, using that property, then we can write this as what? 8 and then 4x raised to what? 1/1. So this is now in rational exponents. Rational exponents. Rational exponents. Again, also, if you have 6 and then 8x here, you're told to write with rational exponents. With rational exponents. Then this is similar to 6, then 8x raised to what? Raised to 1. Another one, if you have 6, the 25 root of 8 cubed in rational exponents form, then this can be written as what? 6, 8 cubed raised to what? 1/2. The same thing, if you have the cube root of w raised to 5, to write that one in rational exponent form is similar to what? This is similar to what? W raised to 5, 1/3, right? And this can be written as w raised to what? Raised to what? If you multiply the powers there, 5/1. Any question after that? Now, write y raised to 3/2 in radical expression. In radical expression. So how will you write that in radical expression? This is similar to what? The square root of y raised to the square root of y raised to 5. Now simplify, let's simplify. -16, 3 over 2. Let's simplify that. Raised to 3 over 2. Now, if you look at this, then this negative is not affected by the power. So this is actually similar to -63 over 1. And this is also similar to what? So this 16 is, so this is actually similar to the negative. 16 raised to what? 3. And this 16 is what? This 16 is what? 4 raised to what? 2. And then all this raised to 3. Now, using the properties in section 5.1, then this is equals to -4 raised to 2 multiplied by 3 over 2. And this is equals to -4 raised to what? 4 raised to 2. And this is equals to what? -16. Any question? Now, another one, simplify 32 raised to -2 all over 5. 32 raised to -2 all over 5. So what did you say in property 5.1? If we have the negative here, to remove the negative, what do you do? Yes, so this is similar to 1 all over 32 raised to what? 2 all over 2 all over. Now, you can distribute this. 1 raised to 2 over 5 is what? Is 1. So it is 1 all over 32 raised to what? 2 all over 5. And finally, this is equals to 1 all over 32 is 2 raised to what? Is it 5? Is it 5?
Yeah, it's 5.
Yeah. So 2 raised to 5 is 32. So 2 raised to 5 raised to 2 over 5. And then finally, this is equals to 1 all over 2 raised to 5 multiplied by 2 over 5. So that and that will cancel. So finally, this is 1 over 2 raised to 2. And this is equals to 1 over. Any question up to that? Another example, if we have r raised to 5 all over 2 multiplied by r raised to -1 over 2 all over r raised to -3 all over 2. Simplify. Simplify. So how will we simplify? So using the properties in section 5, then we can be able to simplify. So we can be able to simplify. So this is equals to the bases are the same in each one of them. So we do what? We add and subtract the parts. So 5 all over 2 plus 1 over 2, which would be -1 over 2. Bring this one up here. Bring this one up here. It becomes what? positive, right? So when you bring this one up here, it becomes plus one. Since it was negative. So when you bring it up, it becomes plus. So finally, this is R. Our least common factor there is what? 2. So 2 divided by 2 is 1. 1 times 5 is 5. Minus 1 plus 2. And finally, our R is equals to 5 minus 1 is 2. So 4 plus 3 is 7 over what? So that one is in exponent form. How about in radical form? In radical form, that is similar to what? This is similar to the square root of R to the 7. Like that. Or you can still simplify. You can still simplify that. If you still simplify that, then this is similar to the square root of, and then this is R raised to 6 and then R, right? 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 And this is equals to the absolute value of what? R raised to 3. And then the square root of the square root of R. Actually, you don't have to put this here. You don't have to put that there. The square root of R. So you can be told to write it in radical form or in exponent form. So this one is in exponent form, and this one is in radical form. Any question? Okay, so if there is no question, I have some questions here that you can try them in the next few minutes. So the next few. So you can discuss it with your friend. And discuss it. So using the properties that we have just done. You don't have to do that one. So you can combine the two of these. So the square root of these is the same as the square root of what? Using property that we just did. Property square root of A, B is the same as. You simplify the one which is inside the class. So you can simplify taking these and these, taking this one and this one, and then now coming and subject to one. That is simplifying the one which is inside. The same thing with this. So we know that this is what? Odd, right? So we can still get the what? The cube root of the negative.
Yeah.
So if it was even here, then since this one is negative, then we could not be having that solution. So if it was even, then and this one is negative, then we do not have the solution. But this one is odd. So that means we should get a solution. So you can actually get each one of them. 1 raised to 1/3. The next one raised to 1/3. The next one raised to 1/3. For this, since these roots are the same, then what happens here? You can get the root of the all of it. And then you simplify what is inside. So what is inside is 44 divided by 9. Y raised to 6, and this is y raised to 2, you get 2 up here, x like that. And then now you can apply the roots. Again, the same thing. So you can discuss with your friend, you can form a group of 2 people or 3 people who want. X raised to 11, X raised to 10, X raised to this can actually. Yeah. Now, are you able to do that? Anything else? So you see this equal. The lower is. You contact. This is next to 5. Yeah. Next is next is 6 plus 5. So if you look at number 1, so number 1 is what? The square root of x raised to 5, y raised to 9, z raised to 6, square root of x raised to 6, y raised to 5. Right? So this is similar to, this is actually similar to the square root of x raised to 5, y raised to 9, z raised to 6, x raised to 6, y raised to 1. Right? Now you collect the like terms, you get a square root of 1. So this x and this x is 20. X raised to what? 11. Do you have y? Another y? Yeah. Y is 14. And then z raised to what? 6. Z raised to 6. So finally, this is equals to the square root of what? So this is 20 is 4 and what? And 5, right? And then x raised to 11 is the same as x raised to 10, x raised to 1, right? Right? And then since this one is even, so this is y raised to 14, and then z raised to 6. Z raised to 6. Now, distributing the root there. So the root of 4 is what? 5 will still remain inside since we don't get the root of 5. The root of 10 is what? X raised to what? The root of 6, x1 raised would remain there. The root of y raised to 14 is what? Y raised to 7. The root of z raised to 6 is what? Z raised to 3. What remains is what? Square root of what? 5 and what? This one is even. The root here is even. Then here we put the what?
Absolute
The
value.
absolute value.
In Newton.
What's that?
Wrong in Newton on the whole. You're wrong if you include the 2 as an absolute value.
If you do what?
If you include 2 as an absolute value on Newton.
So it says 2 is not the absolute value
Right, it'll be 2 an absolute value, all the variables.
of this one.
Yep.
Newton is wrong. But anyway, you need to put it like this.
So including the 2 values. I just wanna make
Yes,
sure.
you
Okay.
must do. Newton is an application, so
So how do you know when to put those absolute values? for sure?
when n is even, I said,
Okay,
when the root of n, a raised to n, is equals to the absolute value of a if n is even.
so when that root is even, then it becomes. the
Yes,
absolute
this is
value. Okay.
n is even.
So what if the a to the n isn't the same n as the root? So like if it's the third root of a squared? Or is that
If
what-
this one is 3. So actually, this is the same as a raised to n, the square root, the nth root, is the same as a raised to n. Raised to what? 1 over n, right?
Yeah.
So when you distribute this power here, then it becomes what? A raised to n multiplied by 1 over n, right? Which is equals to what? 8. Now, since this n is even, then you put what? The absolute value. Okay? The absolute value. Any question after that? So using these steps here, you follow the steps slowly, then you can be able to do the next questions there. You can bring it back on Wednesday, so we go and do it and then bring it back on Friday, sorry.